Here we're given another differential equation and we're asked to find the general solution. Again, we want to remember that when we're trying to find the general solution to a differential equation, we are going to use separation of variables. This means we're getting all of one variable on one side and the other variable on the other. Here I see that we are given dy over dx equals 6x times y minus 1. So let's get that y minus 1 to the left, and let's get the dx to the right. So I'm going to divide both sides by y minus 1. So I'm going to get 1 over y minus 1 dy dx times equals 6x. And then let's multiply by dx on both sides so we can get that dx with the x variable. So here we have 1 minus y over 1 times dy equals 6x times dx. Again, remember that this is not actually a, dy dx is not actually a fraction, but we're using it like one because of Leibniz notation for representing the derivative, and it's just a very helpful way to look at it. What do we do at this step? The next step we have to do, now that we have our variables separated, is integrate. So we're going to do the antiderivative of both sides. The antiderivative of 1 over y minus 1 dy, that is going to be the natural log of y minus 1. And that's going to equal 6x, the antiderivative of 6x dx is going to be 6x squared over 2. 6x squared over 2 is the same thing as x squared over, or 3x squared. Let me write that out. 6x squared over 2 plus c. It's going to write another line. ln of y minus 1 equals 6. That 6 and the 2 will divide to leave 3. 3x squared plus c. Alright, then what do we do next? We need to exponentiate because we don't want ln of y minus 1. We want y by itself. So I'm going to raise both sides to the e power. So I'm going to write that. Or e to the power of both sides by exponentiating. E to the power of natural log of y minus 1 equals e to the power of 3x squared plus c. These e's, they're going to undo each other. The e and the ln are going to undo each other because they're inverses, and so we're going to be left with y minus 1 equals e to the power of 3x squared plus c. As a reminder, that plus c in the exponent here tells us that we're going to be multiplying our e to the 3x squared by some constant c. So I'm going to rewrite that now as capital C e to the power of 3x squared. Again, we want y by itself, so we can discuss this as a function, and so we're going to be adding 1 to both sides. And so we'll find that our final response is c times e to the 3x squared power plus 1. And by separating variables and then using the antiderivative, we were able to find the general solution for this differential equation.